Hi, I would like to further our talk with factoring and set up factors that are in an equation. And we're going to use a principle called the principle of zero products. And Professor Know-It-All is going to help us out with this. Hi, Professor. Could you explain this property to us?
This property says that if you have two factors like a and b and they're set equal to 0, at least one should be 0. Let's take a as 0. Okay, that works. Let's take b 0, and that works. Now, this can be further extended to three factors, let's say a, b, and c. At least one of them must be 0.
Okay, thank you, Professor. This will be useful information. And maybe you'll stop by and help us out again some other time. Thank you.
I will.
Okay, we're going to use this principle of zero products to solve some equations involving factoring. So here we have two factors, and the professor says that when you have two factors like this multiplied together and they're equal to 0, at least one of them has to be 0. Now the trick is set both of them equal to 0, both factors equal to 0, and solve them. And we get solutions of x equals -7, x equals 8. If you substitute those one at a time back in for x, at least one of those factors is going to be 0. So let's take the case of this other problem here. Two factors multiplied together equal to 0. Let's set each one of them equal to 0. And work them out separately. So on the left-hand side here, we should work this out, and we'll get x equals 1/4. Now, if you take that 1/4 and substitute it back in for x in the original equation, at least one of those factors is going to be 0. In the case, the furthest one on the left there, 4x minus 1, substitute that back, that becomes 0. And in our other solution, x equals -5/3, do the same thing. The right-hand parentheses there will become 0. Now, here we have what's called a quadratic equation, and that's determined by the fact that you have a 2 as an exponent there. And it's also in a form, it's called standard form. There's a descending order of exponents, and the whole thing is set to 0. Now you could factor that and solve for y in each of the cases, and our solution will be y equals 1 and y equals 3. Now, you should always check your solutions, because it may be that they won't work. In this case, they do, and I'll show you how to check them, and I'm not going to check the rest of them, but I'm just going to check this one problem here. So let's substitute 3 back into the original equation here, and we find that both sides come out to be 0. That means that our equation is balanced, and that is the solution. Now let's substitute 1 in for y this time, and work that out, and we see that both sides balance out. So these are indeed our solutions to our problem. Now, in this case here, we need to move the 3y onto the left-hand side. So let's subtract 3y from both sides. And then we have a quadratic in standard form here. We can go ahead and factor it. And then we want to take each one of the factors and set them equal to 0. This is a principle of zero products. And we should come out with y equals a -2 and y equals 5 as our solution. Again, you should check this out by substituting those y values back into the original equation. Now this one here is a difference of squares, and we're going to rewrite it so that you can see that it's a difference of squares. And from our last lesson or so, we determined that it fits a certain form. It's quantity x minus 3 times the quantity x plus 3 equals 0. Set each one of those equal to 0, solve for x, and you should get x equals 3, and you should get x equals a negative 3 for your answers. So let's see what we got coming up here next. This one's a little more complicated. Let's start with the right-hand side. Let's multiply the two factors together using that FOIL method, where we multiply the first terms together, and then the outer terms together, and then the inner terms, and then the last terms together. And that will give you the right-hand side here. Now, let's take everything that's on the left-hand side of the equal sign and subtract it from both sides, and we get a messy situation here that can be cleared up if we take and combine our terms, our y squares, our y's, and the numbers together. And then we get something that looks a little bit cleaner here. And then we can take and factor this and set our factors equal to 0 and solve each one for y. And we should land up here in the end with y equals 13 over 2 and y equals a negative 1. If you put those back in the original equation, both sides should balance. Now, our last problem is a cubic equation determined by the fact that we have a 3 as an exponent. Now, let's try to simplify this a little bit. Let's take the first two terms and factor out the greatest common factor, in this case x squared, and then let's group the last two terms and factor out a negative 4. And then we see that we have a 5x plus 2 that we can factor out, and that will lead us to our third line here. Now, the x squared minus 4 could be further factored into x plus 2 times x minus 2. So we're going to come out with 3 solutions here, and here they are. And thanks a lot.